Hi all, I want to give us a quick introduction to some of the graphs that we're going to be using in our next module. So to keep this video as short as I can, I've gone ahead and added lots of notes. Feel free to pause where you want to and take any notes that you feel. So I'm going to go ahead and get started with what are we looking at when we're graphing. So in this left box here, I have what is called the coordinate plane. A lot of people call this a graph, but a graph is actually the line that you draw on the coordinate plane. The coordinate plane is the grid that we only get to see a small piece of. Now, within this coordinate plane, there are two darker lines right through the middle of it. So let's talk about what those lines are first. The horizontal line here, that is called the x-axis. We read the x-axis from left to right, just like we read a book. There's a reason that I pointed that out first. It is very important. Whenever we're talking about the x-axis, we always look from the left to the right. The next thing that we're going to look at is the y-axis. The y-axis goes from the bottom to the top. All right, you grow up, you don't grow down. So if we have a grow up, then on this case, we are going to look at the graph from the bottom to the top. That is called our y-axis. Horizontal line is the x-axis, vertical line is the y-axis. Now, the next thing that we noticed, it looks like it's broken up into four small little boxes. Each of those boxes is called a quadrant. Now, when we're labeling these, they're typically not going to write the word quadrant. They're just going to put the Roman numerals 1, 2, 3, 4. So how do I know where they go? Well, if we're talking about the coordinate plane, think about drawing a C in there, starts at the top right corner. Then it goes to the top left corner, the bottom left corner, and then the bottom right corner. So when we have that coordinate plane, every one of those boxes actually tells us something. Everything in quadrant 1, x and y values are both going to be positive. So here, this is where we put positive, positive. Everything in quadrant 2 will have a negative x value and a positive y value. Everything in quadrant 3, the x and the y value will both be negative. In quadrant 4, the x value will be positive and the y value will be negative. So there's a lot of pieces there, but there's one more thing I need to cover in this coordinate plane. It is called the origin. Now, the origin is where we start to count our boxes from. So this part here, the little dot right in the center, this is where the entire coordinate plane starts to originate from. So this is called the origin. It is located at the point 0, 0. Now, 0 is neither positive or negative, but you'll see that a lot of times we use the origin with our graphs. Not always, but a lot of times. Another thing that I want to talk about is some of the vocabulary that you'll use. We are looking at the x values and the y values. X can be referred to as input. Y can be referred to as output. Can also be referred to as domain and range. X and f of x. Again, anytime we read a graph, we're reading it from left to right if we're talking about x, and from the bottom to the top if we're talking about y. Now let's go ahead then and let's look at a couple of these graphs. They've got some really cool pieces about them, and we've got to be able to recognize those pieces. The first graph we're going to talk about is a linear graph. A linear graph, it's actually right in the name. What's it going to look like? It is going to look like a line. Now, all of these that I'm graphing today are going to be positive. They're all going to be what is called the parent function. That means it is before it moves left or right or up or down. Okay? So I've gone ahead and graphed some points here that I know would be on my linear graph. So when I draw this graph, I'm going to draw it from the left to the right. I'm going to go all the way through the coordinate plane. Okay? So when I draw this, the left side has an arrow from the left to the right, which also has an arrow, which means this graph goes on forever and ever, even beyond the coordinate plane. This is just a small piece that we see about it. Notice that this one in the parent function, it actually does go through the origin 0, 0. Again, that doesn't always happen, but occasionally it will. So why are these equations important? How do I know by looking at the equation I'm going to be drawing a linear graph? Well, anytime that you're looking at this, either of these equations, if you notice that it has an x here and there's no exponent that you can see, there's actually an exponent of 1. We just don't write the exponent of 1. So y equals x, that draws a straight line. Then we have y equals mx plus b. So it's just x, so that's also representing a linear graph. Now let's go look at two more that we're going to be looking at this unit. The next one we're going to look at is a quadratic. So a quadratic is actually my favorite. It's got lots in the formula that we use, but a quadratic graph is U-shaped. Now a quadratic graph is called a parabola. And when we get to this one here, we're going to start drawing from left to right. So when I draw this one here, I start at the left side, go down to the origin, and come back to a rising position. Now that's very crooked because I'm trying to get it to draw something. Let me see if I can do this here. So if I have this, there we go. So now on a parabola, this one has a curved bottom, somewhat similar to a U shape. There is an arrow on the left side because it does continue, an arrow on the right side because it also continues. So this one here, U-shaped graph. So how do I know by looking at my equation that it's going to be a U-shaped graph? I'll tell you. So a U-shaped graph is always going to be x squared. The x with the highest exponent is x squared. Now, yeah, there's an x here, but that x doesn't have an exponent on it. So I look for the one with the biggest exponent, and that would be x squared. So anytime you see x squared, you're going to draw a parabola. Now let's go on to our last one, which is an absolute value. This one here is absolutely straight lines. This one is going to make a V shape. Drawing it from the left to the right. So let's start here. It is decreasing. Oh, keyword, decreasing. Then it hits the origin, and then it starts to increase. So from the left to the right. Now, this one has some equations that I actually wanted to write in with you because I wanted you to see what's different about them. First one was just x, quadratic's x squared. So why is absolute value so different? On this one here, the parent value or the parent equation of an absolute value is y equals, then we have these things called absolute value bars, and the x is inside the absolute value bars. Absolute value just means that any number that comes out of it is going to be positive. It was within that absolute value. So the other equation that we will see in the future is going to be y equals, it'll have a value on the outside, absolute value bar, x minus h on the inside, absolute value bar plus k. So whenever you're looking at this equation, if you happen to notice that the x is inside the absolute value bars, then that's when it's going to be a V shape. All right. So we have three graphs that we just looked at, and the coordinate plane. The last piece that I want to cover, if you've got that information, you're good. You've got a lot of knowledge already. But here's something that I want to cover, just an extra tidbit of information. What is increasing? What is decreasing? Well, increase means something's going up, something is rising. Decrease means something is falling, all right? So let's look at these really quickly. If I look at the linear graph from left to right, this graph here is always increasing. It is always going up from left to right. So that's an increasing graph. Now, the quadratic's a little bit different. The quadratic from left to right, when it started, it was actually falling at first. So that's a decreasing part. But then once it hits the origin or that turning point, it turns around, and now this is increasing. So a part of that graph is decreasing, and a part of it is increasing. Same thing with the absolute value. From left to right, it is decreasing, and then it hits that turning point at the origin, and then it starts increasing. So again, decreasing is falling, increasing is rising. Big thing, whenever you're reading a graph,